is an atom. Already you are aware of all these things in the case of your Bohr's postulates. Bohr's atomic theory. Come across about that atomic physics. Under that atomic physics concept, an atom means there is a nucleus which is a central core of an atom. Central core of an atom is called by the name the nucleus, which carries positive charge. And surrounded by that one, electrons are revolving. The number of electrons and this positive charge, these two are compensated. These two are equal to each other. Hence, an atom is electrically neutral. The total charge in an atom is equal to 0. The charge carried by an atom is equal to 0. That is the meaning. Clear? An atom means it is the smallest particle of an element. If you are considering any element, and if you are go on cut down that one, the smallest particle, the tiny particle, whatever we are getting at the end, that is called by the name an atom. Primary school level already we have spoken about this and we have learned. But as soon as we have grown up, we are going to say atom is further divisible. An atom, we can remove the electrons, we are going to get the nucleus. The nucleus which is containing protons and neutrons. Protons which carries the positive charge. Whereas the neutrons do not carry any number of charges. Charges is not carried by the neutron. Neutron is a neutral particle. It does not carry any charge. Okay. So any atom or nucleus can be represented by a symbol. Hydrogen, capital H, helium, He, carbon, capital C. Is that right? Oxygen, O, like that it can be represented. So here I have written that one with X. But it is having some configuration. What is that configuration? Represented by A, superscript, represented by Z, subscript. Represented by A, X is an element. It can be represented by A and Z here. What is that? Of course, this A and Z we can write like this also. This A can be written here, Z can be written here or here, no problem. And A can also be written here. So this is the different versions that we can write a nucleus or an atom. Clear? X is an element. Where A representing, X is an element, A representing the mass number. Mass number meaning is the total number of protons, how many it is possessing, plus the total number of neutrons, how many it is possessing. Together that number is said to be taken as Z plus N, that is number of nucleons. So nucleon number means, now onwards if I am saying nucleon, what do you mean by nucleon? If I am saying it is the number of protons and number of neutrons together is called by the name nucleon number. Nucleon means the proton number and neutron number together is called by the name the nucleon number. And Z is called by the name the atomic number. Atomic number represented by its number of protons. Total number of protons, how many it is possessing, that is represented by its atomic number, that is represented by the symbol Z. Now let us have one more question. Let us consider one more question, how we are framing. Consider carbon 26 atom. You see the difference between an atom and a nucleus. Atom means nucleus is also there, the electrons are also revolving around the nucleus, together is called an atom. If I am removing the electrons here, you are going to get only the nucleus. If I am talking about the nucleus, I am not going to bother about the orbital electrons. So removing the orbital electrons only, that we are going to take up the nucleus. Nucleus means without the electrons. Here orbital electrons. Now consider here now, an atom here. This atom containing how many number of protons, how many number of neutrons, how many number of electrons. This is the question that we are going to frame. Since it is an atom, it is containing protons, containing neutrons, containing also electrons. Don't forget, since it is an atom. So I will consider here, it is A, this is Z. Here I will use that idea. In place of A, 12 is there. In place of Z, 6 is there. Since it is 12 here now, A is equal to Z plus N. Same thing here, Z plus N. A is equal to mass number, is equal to number of protons plus number of neutrons, Z plus N. Z is equal to here 6, that is the number of protons. Z representing the number of protons. So Z value is equal to how much? 6. That 6 I have written here, N is equal to 12. Therefore, N is equal to 12 minus 6, you are going to get 6. Therefore, I can say it is containing 6 protons, 12 minus 6 number of neutrons it is containing, and it is containing the same number of how many protons it is containing, same number of electrons which is present outside the nucleus. Therefore, it is containing 6 electrons also. Okay, so what we will write, I will write here now, it is containing 6 electrons. Because it is said to be an atom is containing protons, neutrons, as well as outside the nucleus, the electrons are also involved. Follow this. Now let us consider only the nucleus. This nucleus containing, which are the particles? Don't forget, it is not containing any number of electrons. Electrons it is not possessing, because I have taken about only the nucleus. This nucleus containing 92 number of protons. It is containing 238 minus 92, A minus Z. 238 minus 92 number of neutrons. And it is not containing any electrons. This is the mistake while writing at the time of exam you are writing. You are doing that. If this is the nucleus, how many electrons it is containing if they are asking the question? Okay, openly you have to say, since it is a nucleus which is not containing any electrons. Electrons are present outside the nucleus, but inside the nucleus it is containing only the protons and neutrons. How to calculate the number of protons and number of neutrons? Z value, A minus Z is equal to number of neutrons. Is that right? So maybe carbon 12-6, another example that it has been taken here now, it is a nucleus. Again, it is a nucleus, I have written. This nucleus is containing 6 number of protons, 12 minus 6 number of neutrons, and the number of electrons it is possessing is equal to 0. Are you following this? Clear? So now, let us consider XAZ nucleus here. What is the charge on this if they are asking? How many protons it is containing? Multiplied by 1 proton charge. The number of protons it is containing is equal to Z. Z number of protons it is containing. 1 proton charge is equal to plus 1e. Plus e or plus 1e, it is equal to 1.6 into 10 to the power of minus 19 coulomb. Electron charge is negative, proton charge is positive, nothing else. Okay, the magnitude is remains same. The magnitude of electron charge and the magnitude of proton charge remains same. But only thing is, electron carry the negative charge, protons carry the positive charge. Now let us consider what is an alpha particle, what is a beta particle, what is a gamma particle. Basic ideas only that I will take up the ideas, nothing else. Only the basic concepts. Alpha particle, now onwards. If I am saying what is an alpha particle, if I am saying, or alpha ray, if I am saying, it is a helium nucleus. Helium atom, it is containing 2 protons, 2 neutrons inside the nucleus, and 2 electrons are also revolving around the nucleus. If I am removing the 2 electrons revolving around the nucleus, you are going to get only the nucleus, and hence it is a helium-42 nucleus. Since it is loses 2 electrons here, it is containing a charge of how much? Plus 2e, where E representing 1 proton charge, plus 2e representing 2 proton charge. Because it has lost the 2 electrons here now. Since it has lost 2 electrons, it is containing plus 2e or plus 2, no problem, you can write. But E representing 1 proton charge. Consider the next particle, that is beta particle. In the case of radioactivity, if I want to take up in future classes, this is a radioactive substance if I am choosing. From that radioactive substance, alpha rays are coming, beta rays are coming, gamma rays are also coming. Alpha rays, beta rays and gamma rays. So without understanding what is alpha, what is beta, what is gamma, you cannot understand all those concepts. So therefore alpha particle means it is a helium nucleus which carries positive charge, double plus. Beta particle means a fast moving electron. An electron, you are aware of an electron. If an electron is stationary, which is not called by the name of beta ray. If the same electron, if it is running at a high speed, which is moving with a high kinetic energy, I can consider that one as a beta particle. So beta particle means, you have to remember that, a fast moving electron is called by the name of the beta particle. Since it is an electron here, that configuration that I have written E0 minus 1. Therefore, electron charge is minus E. Therefore, the charge of a beta particle is also equal to minus E. Whereas a gamma particle, if I am considering, or a gamma ray, which is an electromagnetic radiation, which is an electromagnetic waves of a shorter wavelength. So you know about the electromagnetic waves, different electromagnetic waves, whatever the family members. Okay, gamma rays, cosmic rays, gamma rays, X-rays, then ultraviolet radiations, visible light, then below that one it is infrared rays, microwaves, radio waves. They are all electromagnetic waves. Out of that, the shorter wavelength region is said to be taken as gamma particles, which is highly energetic radiations, very dangerous radiations. And these radiations are not having any amount of charge, but these two are having the charge. Since it is having more charge here, ionizing power is very large. It is having lesser charge here, ionizing power is lesser. This is having zero charge, ionizing power almost equal to zero, but I cannot say it is equal to zero. But energy wise, if I am considering, this is having more energy, this is having lesser energy, this is having still lesser energy. For example, if you have taken a sheet of paper and alpha particle, if you are putting in one side here now, as it is okay, hitting or maybe the incidenting on one side of a paper, through the paper it will not pass through. Which one? Alpha particle. Whereas beta particle, gamma particle, easily it will pass through because energy is less here. But these energies are more. Almost I can say that this energy is 100 times more than this, approximately. This energy 100 times more than this. But this energy, almost 100 or more than that times, it is greater than this. Approximately. For example, beta particle, even if you have taken a dictionary, you are aware of dictionary, have you seen the dictionary? At least, okay? It is a big book. Okay, through that one, beta particle will not pass through. It will not pass through, it will absorb there only. But gamma particle, easily it will pass through. Don't forget, gamma particle, even if you have taken around about 6 inches of iron or something, imagine 6 inches of iron, around about 10 feet of concrete, cement concrete, gamma particles easily it will pass through. Such energetic radiations are gamma radiations. Gamma radiations are energetic radiations. Because of that one only we are going to say which is more dangerous compared to these two. But ionizing power is very large. Okay, this ionizing power wise, if you are considering, this is also dangerous if that is the case. If any body, if it is okay, on which it is going to be get incidenting, maybe a gas molecule. Through the gas molecule, if the alpha particle it is passing, then it is absorbing the 2 electrons, that is losing the 2 electrons. Easily it will ionize the gas through which it has been passed. Clear? This is only the basic differences that I said. Okay, whatever the syllabus it says that we have to think about in later.